In moving to a low-carbon economy, the role of buildings is absolutely crucial. Working with buildings, finding a way of reducing those carbon emissions from buildings, both in their construction and their use, is absolutely critical if we're to meet the challenge of climate change, moving to a low-carbon economy over time.
And our role is to help business and the public sector make reductions in emissions to make a low-carbon economy a reality in the UK. And what that means over time is we need to reduce carbon emissions by 60%, probably at a minimum, by 2050.
One of the big issues with buildings is getting developers, getting builders, getting tenants and landlords to see that there is a business case in refurbishing buildings to a higher standard than is always required. Actually recognising that going the extra mile has a significantly positive payback.
For us, the Low Carbon Buildings Accelerator work has been all about real-world projects. So for us, it's about getting involved, rolling our sleeves up, seeing how these projects actually work, learning from industry and working with industry and all of the various players within the construction sector to understand what happens currently, to try and bring in some low-carbon expertise alongside that, to try and encourage managers, engineers and architects and all those involved in the process to perhaps think about the carbon-saving agenda alongside all of their other priorities for projects, to understand which things are cost-effective, which things might be nice to have but aren't achievable perhaps this time but might be something to consider in future.
We believe that actually low-carbon refurbishment makes business sense for a couple of very good reasons. Firstly, embodying energy efficiency in the refurbishment process will lead to cost savings over many years thereafter. Secondly, customers, in the case of buildings tenants, are increasingly demanding low-carbon buildings as they are becoming increasingly conscious themselves of what they can do.
One of the unique elements of the Low Carbon Buildings Accelerator is the fact that we're going through this four-stage process that involves the last stage of monitoring the building. So not only do we look at how this building has been designed and what its energy performance we believe will be, but also we look at, in reality, what have we actually achieved with the building through a year of operation.
In short, we're hoping to demonstrate there are a whole series of benefits from taking a low-carbon approach to buildings within the buildings we're working with, and then we're hoping to take that knowledge and disseminate it more broadly so low-carbon buildings become mainstream buildings in the UK going forward.
So really the message is simple. If you're refurbishing a building, think about the energy use, think about the carbon implications, bring in the right expertise and make that building the best it can be.
We know that commercial buildings represent a very significant chunk of the built environment in the UK, that these commercial buildings are refurbished on a very regular basis. If we can just get that refurbishment cycle to take a slightly longer term view in terms of investing in energy efficiency, investing in green technology, it'll have a massive impact over time on the efficiency that we see through our buildings and our overall carbon emissions in the UK.
What's particularly exciting for me about the MOD project is the level of carbon savings we believe we've achieved with that project. Incredibly significant savings of over 50% for the building we've worked on. And those have come mainly from improvements to the fabric of the building. So simple things that you can do as part of a refurbishment all have played a huge part in cutting the energy use in those buildings by a half. And that, of course, represents the major cost saving for the Ministry of Defence, but also the carbon emission savings there are very large, probably larger than you'd expect to see from this type of project. But no doubt it's encouraging for anyone looking at a low carbon building that we can make that kind of difference with the right type of project.
Built in 1939 in preparation for World War II, the spider blocks at the Army's Brunswick camp in Pirbright, Surrey, are some of the hardest working buildings you'll find anywhere. Every week, these barracks are home to up to 1,400 soldiers passing through on exercise. Elsewhere on the camp, the Army is building new accommodation appropriate for a modern fighting force, and to house troops who stay longer, including new recruits experiencing Army life for the first time. With the new build in progress, there was a need for temporary accommodation for the recruits. The spider blocks were identified as a possible answer. But owners, the DTE, Defence Training Estates, and partner estate management service company Landmark recognised there was an urgent need to update them to make them more comfortable for longer occupation.
Because it was to be for Phase 1 recruits, and that's mummies and daddies, little darlings, just coming straight into the first meeting of the military mind, we could not put them in buildings of this standard.
The troops train very hard during the day, and when you look at 120 plus in a building, and they've just been on a combat fitness test, that's about 120 of them rushing in to have showers. You have 11 showers in the block. They've only got so long to change and get into a different order of dress and out again. They will take punishment, and they've got to be built strong for that punishment.
The design of the refurbishment was a requirement for robust but functional accommodation, so that up to 400 young recruits can come in and out and be warm, dry, be able to wash and shave and all the rest of the stuff that these recruits do.
Yours at the front. We had already been considering refurbishment on a much smaller scale, working room by room, block by block, within our own maintenance programme, but I suggested that we could give up 4 of the 8 spiders within Brunswick Camp to be accommodation for ATR, and that was when the refurbishment was decided on.
Army trainers said, yes, we can do that, we can provide this, because not only does it allow the recruits to be here now, in future, when the tenure of the recruits is finished, we've got it back as training accommodation. What had to be bear in mind is a refurbishment, not a rebuild. So therefore the costs were kept down anyway. And obviously with the MOD budgets and all the budgets that are in line, there are far more higher priorities actually than one may say than refurbishment of buildings. So therefore it was needed to be done as cheaply as possible.
The commercial restraints are there. You've got to work within certain things, and this was a very good example of that.
Now obviously we were going to have to remove the external cladding of the building, the roof and the walls, because of the asbestos. Our greatest risk would be what would be the condition of the steel frame, the steel portal frame buildings with timber studding. The first walls and roof to be removed revealed excellent framing, both the steel and the timber.
And that's where you must start in any refurbishment. You look at your fabric first. Try and get that within your budgets as good as you can get it before you go into the next phase of dealing with the technical aspects of the mechanical and electrical systems.
Last winter I managed to use a thermographic camera, and I walked around site taking pictures of the building and identified areas where there was excessive heat loss. Because the building fabric was so thin and leaky that heat was escaping into the atmosphere.
They've got no means of controlling the heating within them. It's just a central boiler, so it's all or nothing for heating. Insulation was minimal, so they're not very comfortable as such. They provide a roof, but that was all. There was a tendency for the boiler to want to meet the coldest area of the building, so you get some areas were hot, some were cold. The troops would come in and just open the windows. It was all heat that was lost.
This is the actual case study building. Spider B is one of the 4 spiders. 4 spiders were completely refurbished. Well, Spider B was taken as the case study to monitor the before and after energy conservation results.
We went a little bit further on that particular Spider Block B because we put some additional controls in which should prove to be more energy efficient. So if we're able to prove that over the 12-month monitoring period, then it's quite possible in the future the MOD will incorporate that extra level of control.
We're now in one of the Spider's legs, which is a general accommodation for the troops. So what we managed to do is include false ceilings. We've dropped the ceiling here. We've got insulation on the roof space and also insulation on top of this false ceiling. We've got integrated high frequency, low energy lighting. We've also improved the cladding of the building, so reducing the heat loss through the walls. Above each bed space, we've also managed to put the low energy compact fluorescent lighting above each bed space there. We've also obviously got the double glazed window units here. We've installed automatic control valves to the heating system, which is linked back to a central building management system, so it can be controlled remotely. We've also got the time delay switches on all corridors, which make sure that they go off after a certain length of time. So we're now in the plant room of Spider Block C, but this is where the building management system is located. So the automatic control valves, which we saw earlier, they're all hardwired back to this central unit. And here we can see Spider Block B. And now we can see the 6 legs of the spider block, and the plant room, and a small room at the end, with individual inside temperatures shown there. It also picks up the outside air temperature, and it adjusts the heating and the hot water to suit.
The classic is the shower. The young soldier will go out, he'll do his PT, he'll come back in again, he'll go in and have a shower. He knows he's got to be on the square in 10 minutes' time. So he'll turn his shower on, have a shower and walk away. He'll leave the water running. So the little things like having a push and it only comes on for 40 seconds is great, because little Tom will push it, have a shower and walk away and it'll go off. The same with the light. It goes out, the light will go off. And the ventilation system that is in there, that is on movement control as well.
We've got water-saving shower heads, and we've also got the percussion or push taps for the wash hand basins.
It's very important at the start to find out how the building performed in the previous 12 months before the project. So we hear they had very good records of what the use of energy was in the spider blocks. Once we've established that and satisfy ourselves in that, we might go as far as modelling how the building works based on that information. So we establish a baseline, and then we work our way through the case study and the project with the likes of the MOD here. Once we've finished the refurbishment, we set up a monitoring process again over the next 12 months so that we cover the 4 seasons. And then we compare like with like on the building, and that then gives us the figures showing energy saving and the resultant reduction in carbon emissions.
We managed to get additional funding to install gas and electricity and water meters to all the spider blocks, including the 4 blocks that were to be refurbished, so we could get a feeling for how much energy the refurbished blocks were using against the older blocks.
What we must ensure to do is ensure that at the start of the project, all these things are built in at the beginning of the project, and understand that if you change it halfway through, it will make a hell of an effect on cost and on time. So the quality and the carbon-friendly equipment must be thought of right at the very beginning of the project and understood by everybody. Legislation, building regulations actually cover quite a lot of them, like the cladding and the rest of it, and the U values and the windows and all that sort of stuff. But it's the extra bits, the push button, the lights, the bulbs, all that sort of stuff must be thought of very early on.
This particular case study here, you could see where simple solutions have produced a massive decrease in carbon emissions, and for the client, good energy saving. I mean, you're talking on this one of more than 50% reduction of energy.
Well, that's the good thing about energy projects, is that not only does it save money, it saves emissions, but generally it improves the comfort and standard of a building.
In many ways, actually concentrates the mind and actually makes you select the correct items and correct equipment to ensure the complicity with legislation. No, it's not difficult at all.
We've helped them prove that you can do it in a commercially viable way, and to these blocks we've given them probably another 25 years of life at least for something that's less than half the cost of new build.
Every project owner has a standard financial criteria they use to assess what they should include in their project. And certain measures may not meet those criteria, but a very large majority of them do. So whether it's looking at more efficient lighting solutions, whether it's looking at an enhanced building management system or better specification of plant and equipment, there's every opportunity to save money within the normal cost of the project. And really, carbon saving can be cost effective within the metrics that people use to make these decisions.